All right, everybody. Here we are for the CNT 125, the online network management lab, because we can't be in person to do it. So, as promised, I'm going to do a video for this lab for you. Now, my video is going to be a bit different than the actual lab in that I'm going to add another component in here into our subnetting piece, where I'm going to use what's called a variable length subnet mask. So, to start off, you want to make sure you download your packet tracer file, the one that we have here on the screen, and you're also going to want to download the Word document with the directions and instructions on how to do everything that we're going to be covering here today. We're going to be adding a couple features in here. We're going to be setting this network up with some redundant fiber optic links to connect our routers together, and then we'll use our simple network management protocols so that you can see how data comes back to the management information base. I'm going to be covering the component with you on the actual setup, and I'll leave you guys with the actual capturing of packets and where to submit your data. But I'm going to get you through some of the other stuff with configuring the routers, getting them set up, and also helping you out with the subnetting component of it. So let's go ahead and get started here. Now, it says in here that for the lab prep, you want to view the network map that's in the Word document. We're going to subnet it using the 192.168.0.0 with a /16 to create at least 6 subnets. So if you're wondering where the 6 subnets are coming from, you've got a network here, you have a network here, a network here. So there's 3 networks, and then these are also networks here. Now I look at this as a /16, and we're going to be wasting so many hosts inside of here. So I'm going to build this network with a little extra room for growth, and we're going to set it up so we don't waste as many IP addressing in here. I'm doing this just so that, to show you how you would actually do it in the real world, how you're going to end up doing it with Professor Elwell as also, so that you can see what we call a variable length subnet mask. So basically what's going to happen is I'm going to subnet this for the 6 networks, and then I'm going to take that last network and I'm going to subnet that network down into other networks so that we can free up some space. Okay, so let's go ahead and take a look at what we've got going here. So we need to set this up first for our 6 subnets. So if we break this down here, you can see that we started off with a 192.168.0.0, and it was just a /16 network. Okay, we're going to subnet this to create 6 additional subnets. So to do that, if we remember, we have our numbers on the right hand side that I always say. We do our 2, and then our 2 to the second is 4, and 2 to the third is 8. Okay, and we just go on and we do our powers of 2 on the right, and we know here that this number right here is going to encompass the 6 subnets that we need, which means 2 to the 1, 2, 3, 2 to the third. So we're going to borrow 3 bits out of the third octet to create a new subnet mask, which becomes 224. We didn't borrow 5 bits in the third octet. 2 to the 5th is 32, so that means my magic number is 32, and I'm going to increase my networks in increments of 32. Okay, so that created my 6 subnets here. Okay, 1, 2, 3, 4, 5, and 6. Okay, so there's those 6 subnets. Now, if you are also paying attention, you know that I have 8 and 5 bits here, so I have 13 bits here that I'm using for hosts. So I have a great deal of hosts, and these are the 3 networks that I have to complete. I have these 3 here that I can use for my routers, but my routers only need 2 hosts on them. If we take a look at our map, I need 1 and 2. So I've got I don't know how many thousands of IP addresses available here that are going to waste. So what I'm going to do is I'm going to subnet my subnet here. So I took this this network here, okay, my because I created 8 networks in total. So I took one of these extra subnets here when I got down to the 224 subnet, okay. Right, when I got to this guy here, actually this guy wouldn't be 224. The next one here would have been, let me see here. I jumped the gun here when I was just going crazy. So I have my 128 subnet here. Okay, so the next one up from there would have been the 160 network. So let's do our 192, our 168, our 160.0. It would have had an IP range of 192.168.160.1 all the way to 192.168.196, sorry, 195.254. Would have had a subnet mask of 255.255.224.0. The next one would have been 192, 168, 196.0. Its range would have been 192.168.196.1 all the way to 192.168.224. I'm sorry, 223.254 with a subnet mask of 255, 255, 255, I'm sorry, 224, .0. Now, at this point here, I would be hitting my next one, which is 192, 168, 224.0 network. Okay? That would be my next network. But I'm going to take this network, okay, and create additional networks out of this one. So by doing so, I come up with the 192.168.224 network, which is right here. But I'm going to change the subnet mask from a 224 to a 255, and I'm going to create some additional networks. So then I created the 224.0 network. I created the 225.0 network. I created the 226. I could keep on going and going and going if I wanted to, because I've reduced my number of hosts, okay, from the thousands to 254 usable. But just to shorten things up, and I've given myself more room for expansion here, I'm going to now subnet again the 226 network with a 255.252 subnet mask, and you'll see my range goes from 226.1 to .3. Okay, and 3 is actually my broadcast in that one there. So my range on this one is actually .2. And my broadcast address is 3. My next network is 4. Its first host is 5, and then 6. 7 is the broadcast. 8 would then be the next network. 9 and 10 are the usable, and those are the ones I'll use for my routers to make my life easier. So what you would want to do at this point here will be to jot down your addresses that you're going to use on your map. Now, the reason I'm doing this, a couple reasons I'm doing this is, one, you're not going to variable length subnet mask your routers. I'm just showing you how we would do it if we were going to be setting it up in industry. I wouldn't waste thousands of hosts on hooking up 2 interfaces on a router. So you will set yours up using the network 4, network 5, and network 6 for your routers. Okay, unless of course you are versed in variable length subnet masking, that is up to you. So I just want to show you how I came up with my IP addressing scheme. And you will come up with yours. As you know, I like to reduce these here so that everybody can be seen on the network. So I like to make everything a little bit smaller. There we go. I'm just going to put some labels in here so that I can, so we understand what our networks are going to be. So I'm going to say this guy over here this is going to be network 1. This is going to be network 2. Network 3 is going to be over here. So that when we're talking about our networks, we know what we're going on and on about. So there's that network. Okay, we're going to have to wire them all up. It'll make a little more sense once we wire them up. Okay, I'm not going to label the networks 4, 5, and 6 internally right now because it would make our map just a little bit too busy. But these are our networks for the outside that we have to compensate for, and my internal networks will be 4, 5, and 6. So if I needed to, I could say 4, 5, 6. All right. So right now, it kind of doesn't make a whole lot of sense to us, but it will once we wire it all up. Right. Which is our next piece. Now, internally in here, we're going to use straight through cables to wire all this up. So that's not going to be a big issue. So let's go ahead and wire them up. So this guy, we're using G00. He's going to plug into port. If it were me, I'll be plugging it into G01 because I want to keep that gigabit speed going there. It doesn't really matter where we plug this in because we're not doing any inner VLANs or VLANs on these. So we can just go ahead and plug them up. Let's do the same thing over here. Let's go ahead and plug in our G00 port here. Okay, so our network's almost built. Now, we would like to use a fiber optic connection to go from here to here, here, and here. But as you see, if I try to do that, I don't have a connection that I can use for my fiber. So I'm going to need to turn off my routers and then add some fiber ports to our connection. So let's go ahead and start off with adding the fiber optic port to router 1. Okay, so we're going to need to literally turn off the physical switch of our router so that we can add a fiber optic port into here. So right here on the back of your router, you've got that 1-0 switch right there. It's when you first ever encountered binary and didn't know it, that the 1 means on, the 0 means off. So we're going to go ahead and we just turn it off, just click it, and you'll turn off that router. The next thing I want to do is over here is I want to find the fiber optic switch or port that we're going to use. So it's an HWIC 1 gigabit SFP. We're going to take this and we're just going to drop it right into there. So now I've got an SFP that I could port that I can plug into here. So we drag that into our module on the far right. And then we're going to go to our modules on the left hand side here again. And we're going to get the SMD, which just drop that right into there. And that allows us now, as you can see down here in the bottom, I can actually put in my LC connectors into those and connect everything up. Let's go ahead and turn our router back on. I'm going to close out of that window. We're going to do the same thing for our R2 and our R3 routers as well. So let's go ahead and get into those. Go ahead and shut that off. I'm going to grab my SFP port and put that in there. And then I'm going to grab my SFP module, slide that in, turn my router back on. And let's go ahead and complete the same process with our third router. And turn our router back on. So now I should be able to connect my fiber optic links. Now, what we have to understand is some of these guys here are going to need 2 modules, because I just connected 1, right? So let's go ahead and shut this guy off again. We're going to have to do this twice, because we have to make sure, because I have two connectors coming in here. Right. So now, as you can see, I have all of my network is all wired up, and you can see with my labeling now, each individual network kind of just makes sense, right? And it should look very similar to your map. If you have anything different, it might be like I have G0 going here into G00 up top. This one here, I have G01 going into 00, and then, but you're just gonna need to know how you did it. I did 1-1 on the bottom on this one over here. Okay, smart money would have had 1-1 going into that one over here, and then just done zeros up top. But I didn't do it that way. That's okay. Now I have to, but that's not how it is on the map either. So you go ahead and plug it in based on the map, and then it'll make it easier for you to go ahead and, so I'm going to delete those two there. I'm going to plug this one into 0. And that one's going to go into 1. And then this guy is going to go into, I want to keep 0 so my up top. So now I got 0, 0s up top. Oh, my bad. There we go. And I have my 1, 0 on the bottom there. Couldn't do with zeros the whole way around. Doesn't work. Okay. All right, so I'll go ahead and get yourselves all wired up there. And now, as you see, all my links are down except from the switch to the actual devices, because until you program your routers, nobody's really up and running. Right? So the copper links are all set up. Fiber links are all set up. So let's just go ahead and let's hop into our switch, because switches also give us the ability to do your typical SNMPs. So in this part of the lab, we're going to complete the necessary configuration for the switches in our network. We're going to configure them with a name. We're going to give them an IP address. We're going to give them a banner message. We're also going to give them an enable password, a console password, and then a remote password so we can access them remotely. And then we're also going to set up SSH and SNMP. Okay, we're then going to use a configuration management technique of saving a config from the switch and then editing the config and then loading the config to another switch, so we don't have to do the exact same thing over and over and over and over and over again. So in this case here, we'll be able to just program one switch, make some small editing, and then just copy our configs over to the other switches. It's really cool technique, and we use it all the time in industry. So for example, like if I were going to set this network up for a customer, I would actually build it all in Packet Tracer, put it onto a text file, and then I would take that text file out to the customer's premises and load up my routers that way. A lot easier. So let's go ahead and hop on SNMP1. We'll get into our CLI interface. Normally, obviously, you would be consoling in, but this is the simpler way of doing it. We're going to go into configure T. We're going to give it a host name. And this first one is supposed to be SNMP switch. Cisco switch 2960 host name SNMP _S1. So let's go ahead and give it that. Easy enough. Now we're going to give it a banner MOTD. So it's our message of the day. You choose your delimiter. I'm going to go ahead and use a $. I'm going to say never want to use welcome to SNMP1, because that tells people that welcome to SNMP1. If you shouldn't be here, then leave. And I finish it out with another $. So now when we log into SNMP1, when it first boots up, it'll give you that message. We're going to create our privileged exec password. So enable secret class. Now we're going to set up our console password. So we're going to say line con 0 for the console 0. We're going to make the password on this Cisco, and then log in local. And then we're going to exit out. Next I want to set up is my line VTY 0 to 15. This is my remote access password. Transport input SSH. Login local. Okay, so next thing I need to do is I need to set up that local, where we keep telling the console and the VTYs, hey, when people log in, you want them to use the local database. Well, we better set that local database up. So username, test, and the password will be password. In order to do SSH, you have to have a domain name. So we'll say IP domain -name cnt.org. We're going to create our crypto keys. Okay. It says that there's keys already created, and we're going to go ahead and say yes to replace them. We're going to make it 1024, not 512. And now our keys have been generated. So the next thing we want to do is we want to set this bad boy up so that we can monitor for any errors that might be occurring on the network. So we're going to do snmp-server community public, okay, and we're going to give it read and write access. We're going to go ahead and exit out, and let's just go ahead and do a show run, see what's going on here. You see our password's been encrypted. We can see our IP address, our IP domain name is cnt.org, and the username is test, and the password is password. You also can see that our welcome to SNMP1, if you shouldn't be here, then leave message will appear. The password for the console is Cisco. And then that SSH has been set up for our remote access. Okay, if we're happy with that, we do a copy run start to copy the running config to the startup configuration. We see that we have startup config listed in brackets, which means it's a default. We do not want to change that file name, so go ahead and hit enter to confirm it. And we have now saved our configuration into NVRAM. So now what we want to do is we want to be able to, we did miss one piece in there that for remote access, and perhaps maybe Professor Brown is planning on going back into that later on. Yeah, it looks like he does in a little bit. He's going to go back in and change that. But what we're going to do, I'm actually going to do mine now. If I'm going to make this network here, okay, the network 1, based on the IP addressing scheme that I have here. So if this is network 1, it's going to be my 0.0 network. My router will get the 192.168.0.1 address. So I'll get my switch the .2 address, all on the 255 to 224 subnet mask. So I'm going to go in here first, okay? And what I need to do is create an IP address for Vlan 1. So I'm going to say config T, and then interface Vlan 1. You see my IP address is my prompt has changed. I'm going to do an IP add 192.168.0.2 with my subnet mask, and I'm going to do a no shutdown because it's an IP, it's an interface that got an IP address, therefore it has to be brought up. Now, I need to create this configuration on switch 2 and switch 3 as well. I could go through the hassle of retyping everything out, okay, or I could do show run. Let me do my copy run config first because my IP address was put in there. So Now I'm going to do my show run. I'm going to go all the way through to the end, okay? Now I'm going to copy all this to my clipboard. From show run, really just from host name is all I need to do. So we're going to go to host name. Now, if I was in PuTTY, I would do a Control C. If I was in TerraTerm, I would do a Control C. In Packet Tracer, I have to come over here and hit the copy. Then I come over, I'm just going to open up Notepad. And I'm going to paste my config into here. Now there's some things in here, okay, so I can say, all right, file, save as, and I'm going to call this one Snmp1, okay, switch 1. And then, because that's my switch here, okay. Everything in here is what I want to be on switch 2, except for the fact on switch 2, the name will change, the IP address will change, okay. So this guy here needs to say no shutdown, okay. This guy here will move to 2. This guy changes to a 2. Let's go to our IP address here, okay. Remember, our network is now going up by multiples of 32. So for switch 2, okay, he would have a 32.2 address. And then everybody else is going to remain the same. So now I do file, save as, and then I hit save. So now you see my file is now, instead of 1, it is now 2. We're going to do the same thing with network 3, or switch 3. This changes to a 64. And my banner changes to SNMP3. Nothing else has really changed on any of this. So let's go ahead and do a file, save as, make sure you don't do a save, and we're going to change this one to 3. And I'm going to choose save. So the next thing I want to do, I'm going to come back to my map, okay, and I'm just going to jump right on to switch 3. Okay, get into my CLI of switch 3. Okay, get into privilege exec mode, get into config T. You can do this too. You can also put those 2 commands in your notepad file if you'd like. So now, since I'm on SNMP3, okay, since I'm on that switch 3, I'm now going to pull up my notepad file for 3. I'm going to copy all of this to my clipboard by doing a control, oh, my bad, right click copy or do a control C. I'm going to come back over to here and I'm going to paste my config right into it. So now if I do a show run, you can see that I just programmed switch 3. Let's do a copy, run, start. And close out of switch 3. I'm going to close out or open now switch 2. copy all that to my clipboard, come over here to switch 2. I'm going to show you the other way to do your notepad file on this one here. So at the beginning of all this, I'm going to do enable, and then I'm going to do config T. I'm going to copy all that to my clipboard. Come over here, just at user exec mode, I can now choose paste. And you'll see I didn't have to, just by adding the lines to my text file, I was able to bring that information up. Now, the one thing that we did here, okay, well, actually we did it. We have our, now if we were to get the whole way out of one of these, let's take a look. Save it. Okay, so my config files are in there. So I save my configs. I'm going to get back on the switch here. And I'm going to exit the whole way out. Okay, now touch return to get started, and you'll see welcome to Snmp1. If you shouldn't be here, leave. Now it's asking for you could consoling in. It's saying username. Okay, my username is test. Password is password. And enable, and then class. And now I'm in. And it should work the same on all of them. Welcome to Snmp2, shouldn't be here, then leave. Username, test. Password is password. Pretty cool, huh? So that was a nice, easy way for us to go ahead and configure the configuration files to each individual switch. Okay, and a real lifesaver too when you are when we're working. Next thing I want to do is we're going to look at the router configurations. So we're going to jump first now into the router configuration for R1. I don't know about you, I'm having a real hard time looking at all those down links. They're just bugging the heck out of me. So now in this part of the lab, we're going to be going to complete the necessary configuration for the routers in our network. We'll configure the name, the IP, the banner message, the enable password, the console password, remote password, SSH, and IP addresses for the interfaces. And then we're also going to set up Ospf for our routing protocol, and we're going to set up Snmp. We need to set up the Ospf so that router 1 knows what's going on with router 2 and router 3 and so on. All that being said, let's console into the router of Snmp1, which we're at right now. We're going to hit the CLI. Obviously, we do not want to enter initial configuration dialog. Let's get into privilege exec mode, configuration mode. And now let's change our host name first. And our host name on this one here should be snmp_r1. We're going to do our banner, MOTD. Welcome to Snmp_r1. Router. If you shouldn't be here, then leave. Let's go ahead and enable our password. So enable secret class. Do our console password just like we did in the switch, line console password Cisco. login local. Let's do our VTY. This is just something you just want to get so used to doing, because you want to make sure that you always lock down your routers and your switches. Keep everything secure and always set them up for remote access. Please make sure that you always have that you double check your passwords on these, that you didn't put a space in there, you didn't capitalize something. Okay. So now our SSH has been set up. While we're in configuration mode, we're just going to go and jump right over to our Snmp, doing a public string, and give it read-write access to our system. Okay. Now, using the map and the subnetting that you have done, we're going to go ahead and set up our WAN interfaces. Okay, so I'm going to open up my, I think I had this one here, says they're just set up as routers. So we'll do, this guy here will be R1. This will be R2. And this will be the network, or actually this is going to be, if we take a look at our network, instead of R1, R2, R3, because that won't work, you have to take a look at the map that we have. And we'll say 4, 5, and 6, because that's important because of where they're going to connect. So this guy here, if doing R1, then we're going to say, all right, so R1 to R2 will be a connection. And then R2 to R3 will be a connection. And then R3 back to R1 will have to be a connection. So let's go ahead and take a look at our spreadsheet. And this one here will be our R1 to R2. This will be R2 to R3. And this will be R3 to R1 and back again. Okay, that's important because you need to be able to make sure everybody's on the same, each group is on the same network. So for example, this has to be a network. So this is the third network. This is the first one that we have set up, and this is the third one that we have set up. I'm going to go ahead and I want to set up these guys here first. So what I'm going to do, I'm going to look at my map and I'm going to identify who's who. Okay, so with that being said, I need to go from 010 to 0000. And those IP addresses on mine, for the bottom one, for R1 to R3, that's going to be 226.9 to 226.10. The top one is going to be doing 000 to 000. All right, so I'm going to write that down on my map. So I have it, because when I'm programming, you always program with a map. Okay, so R1 to R2, go back to my spreadsheet, R1 to R2, which is this guy here, it's going to be 226.1 and 226.2. And make sure you know your subnet mask on it. So there are 3 255s, 252 on mine. On you, you guys are just going to be using these guys up here. So you'll be using, like I'm using these down here that I resubnetted. You're going to be using these guys here. Okay? But I want to make it a little bit different. I want to show you another way to do it. I always like to mix things up a little bit. So this guy is going to be 0, 1, 0. And 2, 0, 1, 0. This is my 2 to 3 connection. And my 2 to 3 connection is going to be using 2265 and 2266. Okay. Now we can go back to our packet tracer. On R1, we want to set up the Wan interface addresses. So this is the Wan interface addresses are the ones that are going from port to port. Okay? You use your map as your guide, how you have them set up. So now I want to get into interface G 0/0/0. And I'm going to do an IP address of 192.168. Oh, I hit something. 92.168. And this one here is going to be 226.1. My subnet mask is 255.255.255.252. Okay. And it liked it, so I do a no shutdown. The other fiber interface on this router is interface G0/1/0, and it will have an IP address of 192.168.226.9 with a subnet mask of 255, 255, 255, 252. No shut. Okay. You'll notice the interfaces are down. They're down because the routers that they're connected to are not up yet. So let's go ahead over to here to the interface of 2. Now we could, if we wanted to, we could go into the text file. Let's go ahead and do that, because that's how Professor Brown has you guys doing it. So let's go ahead and set up this interface here too on S1. And then we'll go into our text file and we'll make all of our changes accordingly that way for each individual router and then dump them in that way. All right, we can do that. Okay, next one I want to do is interface G0/0. Now, based on my map here, this will be network 1. So network 1 is going to have 192.168.0.1, with a 224 subnet mask. And then do my no shutdown on that one. Next, I'm going to want all of my routers to be able to communicate with each other. So in order to do that, we're going to do a router Ospf. Okay, Professor Brown has used the autonomous system number of 2. I'm going to go use 10. I'm using 10 because I want yours to look like the document. So I don't want you guys just copying exactly what I do. The networks, we only put in the networks that we are connected to. So this router is connected to 2 networks. Okay, this router, or 3 networks. So this router is connected to this network here with the 192.168.0.0 network with the 224 subnet mask. It is also connected to this network and this network. So let's go ahead and just put in those numbers in there with their inverted subnet mask. So the first network I'm putting in, network 192.168.0.0. The inverted subnet mask on this, if you remember, you take your subnet mask and you subtract it from all 255s. So 0.0. The third octet was the third octet was 224. So 255 minus 224 is a 31. Okay. Dot. And then the other one was it was 224.0. So 255 minus 0 is 255. The last line here is the area. So in OSPF, all the data on this network must always come back to area 0. You can have multiple areas on your network. This is just a single area network. And everything has to come back to area 0 no matter what. So area 0. Okay. That's one network that I know about. I also know about 192.168. Dot, and if we look over here, okay, R1 also knows about the 226.0 network, okay, and it also knows about the 226.8 network. All right, so let's go ahead and put those in. Okay, so 226.0, and then the inverted subnet mask on this one is going to be 0.0, the 192.168, okay, dot, and now I'm going to have a 255. Did I do what was my subnet mask there? Let me just double check real quick. I don't think it's 255. Yes, it is. It's 255. Dot, and then 255 minus 252 is 3. Coming back to area 0. Oh, I have. No, that's my bad. If I do I look at my subnet mask. Okay, it's 0.0. Okay, 255, 255. Okay, 255 minus 255 is 0.3. Okay, so that one worked. Now the next network that we know about also, we know about the 0 network, and this one also knows about the 8 network, which is the one that, for me, which comes down from router 1 to router 3. That's the 8 network. okay? Because the 4 network is the one that goes from router 2 to router 3, okay? Hit enter on that one. So those are the 3 networks that I know about. So let's do an end. Let's do a copy, run, start. Okay, I'm going to do a show run. Now this one's going to take a little more brains to make your configuration changes, but it is worth it in the end. Okay, so spacebar the whole way through. I'm going to copy to my notepad file all the way up to host name. Put that on my clipboard. Remember, if I was in PuTTY or TerraTerm or MoboTerm or Xterm, whatever one you like, you would just use a Control C. Okay, I'm going to copy that. I'm going to open up Notepad. I'm going to paste it into there. Just to make my life easier, I'm going to do an enable and a config T. Okay. I'm going to name this one SNMPR1. Keep everything as simple as you can. This one is R1. Any interface that has an IP address, you want to give it a no shutdown. All you're doing is adding a line. Okay. So everything is in. I'm going to go ahead and save that file. Then I'm going to come back again. I'm going to do File, Save As, and I'm going to change the name from R1 to R2. I'm going to save that. Now I'm going to go back in and I'm going to make some more changes here. Okay, so now the host name is going to be R2, SNMP R2. I'm going to change my banner of the message of the day as well. To R2. R2 knows about the 0 network, okay, that it has, okay, so the 226 0 network, it knows about that one, but it also knows about the 4 network, but it doesn't know anything about the 8 network, so we're going to change that. On its Ospf. Its gigabit interfaces that it has on R2. R2 has a 010 interface, 010, and it runs a 226.5 address. And its G0 interface on this one here, which we said if this is network 3, and network 3 is a 64 network, okay? So network 3, that will be just our G00. And that's this guy here. So he's 64.1. And network 2 has a 000 interface, and it is .2. So he has a 226, 2, and 5 for his WAN connections. his local area connection is the 64.1 connection. So now I'm going to go ahead, I'm going to save that before I make any more changes or mistakes. You never know. Let's make sure our Ospf is right. So he knows about the 0 network and the 4 network. And his local network that he knows about is the 64.0 network. So he'll be able to tell the other routers, hey, in case you're wondering, over here on the other side, on my local side, I got 64 as well. And we're going to go ahead and we're going to save that file. Okay. Now I'm going to do another save as. And the reason I can edit all this stuff is I have my subnetting chart and I have my map all drawn out. This one's going to be the R3. Now the nice thing about this is I already put my no shutdowns in, right? So I just got to change my IP addressing. Okay. R3 knows about the 8 network. R3 knows about the 4 network. R3 is part of the 96 network if we take a look at our subnetting chart. Wait, I do have a mistake, folks. We have a R2 is part of the 32 network, 3 is part of the 64 network. So I'm gonna have to go back and make some changes here on my map. I just goofed up. Okay, so R3 is part of the 64 brigade. Okay, the Wan interface on R3 going to R1 is 10. That is my 000 interface. And my 010 on R3 is 6. The only thing I screwed up on that one is this guy right here. He's a 64.1. Let's change our banner message of the day. I don't know if I switched that in the last one either. I did, okay. R3. So let's go ahead and save that. I'm going to open up my R2 one and make sure my locals are correct. Yeah, this guy should be a 32 network. No, I was right the first time. 3 is 64. Yeah, my third network, network 3 is 64, and network 2 is 32. So based on my map, network 2, so this should be 32, S2 is 64, so I think I just went backwards a little bit. Oh, my bad. Okay, so let's open up. Network 2 is 60. Network 2 should be 64, which is correct. And then the R3 net, no, 0, 32, 64. Yeah, this guy should be 32. That one. So no. Minimize that. Network 3 is 64. That's off of R2, so he should be 64. So my Ospf reflects it. Okay, good. Let's hit save. Let's pull up R3. Make sure it's correct. Okay. R3 is network 2, so he's got the 32 subnet mask. There we go. Knew I had it mixed up somewhere. And R2 knows about the 32 subnet. But my WAN is correct. All right, I think we have her, folks. All right, so now all of our notepad files should be right. I'm going to go ahead and do a Control A on R3, copy that to my clipboard. I'm going to hop on R3 into the command line. I do not want to do an initial configuration dialog. I'm just going to go ahead and just paste that in there. See what happened. And I did make a mistake. I didn't read in my notepad file. I did not rename that. I do believe I'm on R3 and my host name file says R2. There we go. Let's save that again. File, save. Not the end of the world, folks. You make a mistake like that, you just go like this. Boom. Now you'll notice, you see these adjacencies are being formed. Okay, it's learning, okay, it's trying to learn from the other routers and what's going on. Okay. So now I'm going to open up R2. All right, there's R1, there's R2. Control A, Control C, go to R2. Paste that in there. Now the adjacencies should start being formed on this one as well, as the routers are starting to learn about each other in the network. We can go ahead and fast forward time if we want to make life easier. Okay, so now you see all of our links are up, okay, which means we have all the right network configuration in here. Our links are here. There's nothing going on there. If I look back here, you'll see that my adjacencies are done. So to truly know that the adjacency has been formed, R2, okay, R2 here, he knows about this network. He knows about this network. He knows about this one. He doesn't know about this one, and he doesn't know about that one. So to find out if he truly does know, we'll do a show IP route. And we can look, okay, based on the legend, okay, you can see, okay, because we're looking for anything that was learned through the wonderful world of Ospf. So here's one. Okay, we know about the 32 network, and the 32 network is off of R3. We know, okay, about the 8 network, okay, right here. So it's learning about other networks from. So here's my 0 network. Let's see if he's talked to anybody about what he's got going on. So the 0 network right there has been learned, and the 32 network has been learned. Now also, R2 doesn't know about this network here. Okay, he doesn't know about this connection. But now R2 knows about that connection right there. So that's what's really cool about the whole OSPF thing. And by keeping all of these files on Notepad, if anything goes wrong, one, I got a backup and I can just easily dump them onto a router. It's the same thing when you go to a physical router and you're in PuTTY or you're in TerraTerm or Xterm or Moboterm, whatever your preferred terminal emulation software is, you'll be able to then just copy to your clipboard and paste your configs right onto the routers, and they'll come up immediately. It's so cool. Okay. Now remember, when you do your OSPF, okay, you only put in the networks that you know about. You don't need to put in the networks that you're directly connected to, is what I should say. Okay. So now we've got R1, R2, R3, all programmed, S1, S2, S3, all programmed, all from one initial configuration file. Okay, so once we've got all those configs set up and we've got them all pasted into the router, it's now time for us to do the desktop configurations. Now, in this point here, for me personally, I would be doing, if it were my network, I would be doing all of my desktop configurations in a using DHCP. Just for this lab here, because we only have one workstation for each one. Okay, we have a server, we have a PC, and a laptop. We're going to go ahead and just make sure that they're all on the correct networks. So just go into your desktop program, go to your IP configuration. We're going to go ahead and use the static configuration. Just remember, on PC1 is on your 0 network, so it's going to be a 192.168.0.10. The subnet mask that you used on this was not a 255, but a 224.0. Make sure your default gateway is 192.168.0.1. Let's go ahead and do our configuration for our server. Okay. Professor Brown's got this one set up on the 128 network /124. That's not correct. So we want to make sure, because this network here is now it's all based on your map, but mine has them on the 32 subnet. So make sure you get yours correct. And the last one is our laptop. And our laptop should be on the 192.168.64.10 because it's on the 0 network. And I got him talking to the gateway of 64.1. Now, if all that's correct, I should be able to go into my command prompt. Okay, do an IP config, and I can see that I've got everything correct there. I should be able to ping the 192.168.64.1, which is my gateway. As you see, I can there. If routing is actually working on my network, if all my routers have OSPF adjacency working, I should also be able to ping my 192.168.0.10 PC on the far right side. Let's see what happens. And there we go. So now I know that my router worked. Might as well check the other configuration while we're here, and that would have been our 32 subnet, just to make sure everybody's working. And there you go. So we have successfully set up our network. We verified that we can ping. Okay. And now, other than that, that was one way to check functionality. You see also that the lights are up everywhere. The configuration is up everywhere. We're routing. We're pinging. Okay. Another way to look to make sure things are going, if we were to go to the physical network and actually go into our closet itself, into our corporate office, we would see in here in our wiring closet that there's everything that we've got plugged in. We would actually see that we have link lights and everything else is up and running inside of here in our closet as well. We already checked to make sure that we had functionality. We were able to ping. We were able to ping gateways. We were able to ping the other subnets. Now we want to make sure that we can actually SSH across our network. So let's go back here. So let's go ahead and open the PC's desktop configuration. We're going to go down to the SSH client here. And we're going to put in the IP address of the Snmp R1, which would be 192.168.0.1. Now you can SSH to any of those three interfaces. If you wanted to, you could go to 226.1 or you go to 226.9. Either one would work. The path username should be test. So let's go ahead and try this out. And the password is password. So now we know that we also have SSH working, and it told you that we are on the Snmp R1 router, and it shouldn't be here. Then you leave. Okay. We can also do a show IP route. And we can see that we are routing. You can see that we have learned information from the other devices. Okay. Next thing we want to check on our network here in this part of the lab, we're going to see that we will use our PC to connect and manage the devices on our network through SSH. And we're also going to connect into the TFTP server and verify that TFTP is running. To do so, we're going to go to the server itself. We're going to click on our Services tab, and on the left-hand side, you'll see TFTP. And you can see right here in the middle that the TFTP service is actually on right now. And we've already gone in and we've checked to make sure that our routers are up and running. We did show IP route on our routers already. We were able to ping across, so we know we're good there. So you're going to want to do a show IP route and then collect your information because you're going to have to send that to me. Workstation functionality, we did our ping test already. That was all on page 11. Page 12 was our TFTP server. Now we're going to look to see we're going to do router configuration and management with that last piece there. We are going to SSH back into our router. Just for giggles, let's go ahead and use one of the different addresses, 192.168, just to show you that we can do that. We're going to use 226.9. Username is going to be test. Password is password. Okay, so as you can see, I can SSH to any one of those interfaces that I want to. Okay, as long as it's up and running. Now, the reason we wanted to make sure that the TFTP server was running is what we're going to do is we're going to copy this configuration file. We're going to copy it to the TFTP server so that as long as the TFTP server is up and running, we can always have our routers pull their information from there if we need to. So we can just make changes on that server config file and then update our routers accordingly. So we're going to go ahead and we're going to do a copy the running config. And normally at this pace here, we would say copy the running config to the startup config. But instead, we're going to copy it to the TFTP server. Okay, so it wants to know the address of that host. Now, if you remember, we changed it because it was the 128 address. We made it the 32.10, so it's 192.168.32.10. Okay, and then it wants to know the name of the config file. I'm totally okay with that file right there, and we just copied our TFTP, we should say we TFTP'd our running configuration file to that server. So if we ever have to pull it off, we can. Next thing we're going to do is we're going to connect into the R3 router, okay, and we're going to do we're going to clear the config on the Snmp R3. Okay, we're gonna. First thing we have to do is we want to repeat the steps. Okay, so we're gonna view the TFTP server file to see if the files arrived. We saw that. And then you want to click the service tab. Let's do that. Let's minimize this. Okay, so there's our file. So we know that the file got there. Okay. Then we're going to exit out of that. We're going to close our SSH. Then we're going to go up to R2 on the network. We're going to view the logs there to make sure that they've arrived. Then we're going to connect to R3, verify with a ping to the TFTP server address. We're going to copy the SNMP3 from SNMP3 to the TFTP. Then we're going to clear it. Then after it's loaded, we're going to add the IP address back to G0. You have to have an IP address on the router in order to be able to communicate. You just can't say, oh, I'm just going to download it. All initial configurations have to be done that way. So we're out of here. I'm going to get back into this real quick. I'm going to get out of it, out of this session. So let's go ahead and choose exit. Okay, now we'll end our session. Yep. So get out of that client. Okay. Now I'm going to SSH over to my my router 2. So my SNMP2 is 226.2. So it's 192.168.226.2 with the username of test. All right, something's up. Let's see if it's working. All right, it's not letting me in, so we got to figure out why. Let me open up a command prompt. Okay. I can ping it, but it's not letting me SSH into it. So let me just hop on here and make sure I have SSH configured correctly. Yeah, transport input SSH. We should be able to get in. I don't understand why we're not. Alright, so I'm not getting into Snmp2 at all. So let me redo that config. Let's see if we can SSH into this one while we're here. Okay, so the two, looks like my SSH did not take on those two configs. So we need to figure out why. It might be, wonder if my keys didn't take. Let's look. That could be the problem. Yeah, the keys weren't there. So I just need to set those keys up. That's actually one of the questions you'll see on your Network Plus exam. That if SSH isn't working, one of the things you want to do is replace your keys. And the reason I know that keys weren't there is because it didn't ask me if I wanted to replace them. So now I'm pretty darn sure that if we put in the 192.168.226.2 now, yep, we're in. So password is password. And we're in, okay? So let's get into enable and then config T. Oh, gotta put in class. And then now I want to copy the run to the TFTP. And that's going to go to the 192.168.32.10. Okay, that one went over. Let's end out of here. Whenever that happens, man, don't forget, that's why I always do no IP domain lookup. So let's exit out. And we're out. There. And last but not least, let's go over to, that was 262, so now we're going to go to 226.10. So it's 192.168.226.10. Username is test. Connect. Password. And we're in. Class. And then copy the running config to TFTP. And that is at 192.168.32.10. And and say no to that. Now, want to jump onto our server and make sure when we look at the services that all three of your router configs are sitting there waiting for you, and they are. So the next thing we want to do is we're going to clear the configuration of router 3. And then we're going to have to reload the router. Okay, now the router's going to come up, it's going to be dead at the door now. And then we're going to go and we're going to fix that router. Okay, so here is router 3. So we're just showing you how it all works. So test, and then password, enable class, erase, start. And confirm. Now the startup config is gone, but as you can see, we're still running. So we're going to reload the router, which will take it right back in. And we're going to say no to the modification. So we're not going to save it, and confirm with the reload. So now it goes through the reboot here. I'm going to go ahead and just fast forward time. And as you can see, the links between router 3 and 1 are down, and router 3 and router 2 are down, and the link to the whole network itself is down. When a router is down, you still have to console into the router, okay, for initial configuration. So we're going to say no, we do not want to enter initial configuration dialog, okay. We'll say enable, then we're going to get into configuration mode. Right? We have to program one interface on the router. We got to program the G0/0 interface on this router. Okay. Interface G0/0. All right. This IP address is the 192.168.32.1 with a subnet mask of 255.255.224.0. Doing no shutdown. Okay, so now this interface is back up. So if we take a look, okay, you'll see we're green and we're able to talk. This is my TFTP server. So that being said, I have the ability now to actually upload a configuration file from the TFTP server to the router itself. Okay, so now what we're going to do is we're going to pull a saved copy of the Snmp R3 config from the server to the router. First thing you want to do is obviously make sure that the server itself has the ability to ping. So can we ping the 192.168.32.1 interface? There we go. So now we know that we have actual connectivity, okay? So then we're going to copy from the TFTP now, okay? So we're still consoled into the router. And we're going to copy from the TFTP to the running configuration. Okay, the address of the remote host is the 192.168.32.10. Then it wants to know the name of the file. Okay, so now if you remember the names of the files, okay, they are snmp underscore r3-config. If you don't think you can remember that, make sure you write it all in there, okay? And remember that it is capitalized except for the word config. And there are hyphens and dashes in there. So my file name is snmp underscore r3 dash config, just like that, and then enter. The destination file that you want to do is the running config. Yup. Okay. Oh, and it said no such file or directory. So I missed something. What could I have missed on that one there? Ah, it's not config. Okay, it's CFG. So address of the host is 192.168.32.10. The source file name, okay, is, let's bring it up real quick, so we just keep both windows open. Put this all the way over there. See, I put an I in there, and I don't want an I in there. So it is snmp underscore r3 dash confg, just like that. Now I hit my enter key, destination running config. Now you'll notice my host name has changed, but you'll see we're still going to need to rerun our keys. So let's do that next. Okay, they're already here, so we're good to go. They were saved in the config file. We're just going to go ahead and say yes, and we'll make it 1024, and we're good to go. And now the router's back up and running, and everybody's happy. Good. So now that covered that main portion of the lab there. The next piece there, okay, is checking to see if the SNMP protocol that we've been working on, that we set up in our community strings, is actually working. And to do so, we're going to need to add a packet sniffer. We need to be able to see the protocols that are actually running on our network. All right, so now to add that packet sniffer into our system, okay, we're going to click on our end devices over here, and minimize that button there, and we're going to scroll all the way to the right here, and we see we have a sniffer. Now, this is something that we can put in the line to actually see things that are going on in our networks, okay? The next thing we want to do is we also want to add a hub. Now, the reason we're going to do a hub is a hub will actually give us the ability to see all traffic that is occurring on our network. So we'll go over here to our routers and switches, go down to our switches and hubs, and there's my hub. We're going to grab a PT hub. We're going to put that on our network too. Okay. We're going to remove the patch cable between the PC and the switch. I'm just going to grab that right there. I'm going to plug him in to any old port right there. And then I'm going to plug my I had to put a straight through cable from the PC to the hub, and then I got to use a crossover cable to plug the hub into any port on the switch. That works for me. Okay. And then we're going to use a crossover cable to go from the hub and plug it into a port on our sniffer. We put on Ethernet 0. Now we're going to connect into the sniffer, okay, to edit the protocols that are being captured. So I'm just going to go ahead and I'm going to open up my my sniffer. I'm going to click on my GUI tab, and then I'm going to do a show all none, okay. Then I'm going to click edit my filter, and I'm going to click on my miscellaneous tab. And then here you can see that I got my SNMP down here midway in the middle of the column. Okay, on mine. Then I'm going to go ahead and close that window, and then I'm going to hit clear so that everything over here is now gone. And I'm going to close my sniffer for now. Okay. Then I want to generate some traffic. So in real life, there'd be a network management system that would be pulling the network devices and then learning information to store in our database. Now we're going to do that function via an MIB browser to generate the type of traffic that the network management system would then generate. So what we want to do is we want to open up our PC, and we're going to click on the desktop, okay, and we're going to click on the MIB browser, which is not the web browser. This is our management information base browser. Then from here, we're going to click on our advanced button, and we want to make sure that we read the community public string, okay? Because remember, that's what we typed in, public. And we're going to write to the public. Then we're just going to go ahead, we're going to click OK. Oh, we need to put the IP address of SNMB1 right there first. So we want to do the IP address of switch 1. Switch 1, we gave that an IP address of 192.168.0.2. And now we're going to select a new OID. That'll request specific information from the switch using SNMP. So in the bottom left of the window, you want to select the MIB tree, and then we want to select the switch L2, layer 2, hit the arrow, and you want to click the ISO, and then you want to click DoD, and then from there you want to choose internet, from there you want to choose management, from there you want to do MIB, then 2, then system. I have to make this thing a little bit bigger, good heavens. And then we want to choose our system name. Okay. Now you'll notice over here the OID number that's filled in at the top of the window, okay, which is .136.121.150. It's also the same one down here. Okay. Then we're going to go ahead, we're going to click go, and it should start generating an SNMP request to the switch for information, okay, and then we will, oh, we got a problem. SNMP command error, SNMP request timed out. All right, so I figured out what went wrong there. On this piece here in the advanced tab, you pull in the 192.168.0.2. That's the address of my switch. Let the port go. Make sure you put in public here and here. Change your SNMP version from version 1 to version 2. all new versions. This is the current version, but most all versions work with 3. Then you can go over here and you click go to generate your string, and then you'll see information here. So this is what information was gathered, and the gathered all really came up with in this case here was the name of the actual switch itself. Okay. So in the bottom left window, we want to select open the MIB tree again, and we want to go to the interfaces. So we had Internet Management, MIB2, interfaces, and then the if table from here, then our if entry, and then with if entry we want the description. Okay, now we'll see, you see we've got the new number over here. So we're going to hit go on that one to generate information. Let's see what happens. Okay, so now it's taking a look at all the different ports, as you can see, that are actually on our switch, that is and VLAN 1, that it is actually observing. Okay, and basically you're seeing the information going through there. Right. So the next piece, okay, in the bottom left window, select the open MIB tree. We're going to do the same thing, but where after it says the MIB2, okay, we're going to look up IP. I don't have that one. So, we got to do router standard instead. Instead of switch, we're going to look at our router standard MIBs. And then ISO, and then org, and then DOD, then internet, then management, then MIB2, then IP route table, IP route entry, and IP route destination is what we're going to click. You'll see the new number has been put up top. We click up, no command, no such name error, because I need to put in, probably need to put, I would believe if I'm looking up the router, I got to change my IP address. Let's take a look. Yep. So there you go. And then does the same thing again. Okay. So that's just, those are the ports that we're monitoring on our network through our MIB browser. Okay. So that is our lab pretty much done from start to finish. You need to gather your information and submit that to me. And I know it was a long lab, but it was a pretty good one. And I hope you guys got some really good information out of it. I'll see you guys on Tuesday.